All right, let's talk about Bitcoin. Have you ever wondered how a massive global system like Bitcoin doesn't just collapse under its own weight? Well, today we're pulling back the curtain on this really clever, kind of hidden rule that's tucked inside every single transaction, and it's what prevents total gridlock.
So yeah, that's the big question, right? You've got this global network, millions of people all trying to get their transactions through. How does it not just turn into one massive traffic jam? I mean, think about a highway at 5 p.m. on a Friday. There's only so much asphalt, and if you don't manage that space really carefully, everything just stops, dead.
Okay, so the answer starts with this idea that every single block on the Bitcoin blockchain, it's like a tiny plot of digital real estate. And just like real estate in a big city, it's super valuable, and there's a very strict limit on how much of it exists. This creates this incredible competition, right? Everyone wants to get their little piece of it.
And that limit? It's 4 million. But here's the catch. It's not 4 million bytes, it's 4 million weight units. That number, that 4 million, that is the hard and fast rule, the absolute max for every single block. It's the one constraint that pretty much shapes everything else we're about to talk about.
But this is where it gets really clever, because it's not just about how big your transaction is in terms of file size. Nope. The network uses this much more sophisticated system, this idea of weight, to figure out what fits. And the key is, it treats different kinds of data, well, differently.
And that brings us right to the solution, which is called transaction weight. It's a whole new way of measuring things, and honestly, it's the secret sauce that keeps that digital highway from getting totally gridlocked.
So what is transaction weight, really? The best way to think about it is like a system where different parts of your transaction have different price tags or costs. So instead of just looking at the size in bytes, the network actually assigns a heaviness to each little piece of data. And that's what decides how much of that super valuable block space it's going to take up.
So let's put this into perspective a bit. Back in the day, transactions were just measured in plain old bytes. Simple, yeah, but not very efficient. Now we use something called vbytes or virtual bytes. And really, a vbyte is just a handy way to think about weight. Just remember, 1 vbyte is the same as 4 weight units. It's kind of like a bridge that connects the old way of thinking to this new, much smarter system.
Okay, so the theory is cool and all, but I think it's time to see how this thing actually works in the real world. Let's roll up our sleeves, get our hands a little dirty, and actually do the math on a real transaction. Okay, so what you're looking at here, this is basically the official rulebook. Every single part of a Bitcoin transaction. I mean everything, from the version number down to the lock time, it gets a specific factor. And you'll notice right away, most of the stuff has a factor of 4, but a few key things have a factor of just 1. And that difference? That's everything. That's the whole magic trick right there.
All right, to see how that rulebook actually plays out, let's follow a classic transaction, shall we? Our good old friends Alice and Bob are going to help us out. We'll watch them make a transaction and see exactly how its final weight gets tallied up.
So the process itself is actually pretty simple, but it's super powerful. Here's how it goes. First, you take all the core data, the inputs, the outputs, that kind of stuff, and you multiply its size by 4. This is what we call the heavy data. Then, you take what's called the witness data, which is basically just the proof that you own the Bitcoin, and you only multiply its size by 1. That's the light data. And then what do? You just add it all together. That's it. So, for our example with Alice, after we run all those numbers through the formula, boom, we get a final weight of 569. And that number, 569, that is what the miners are going to look at. That's what tells them how much space her transaction takes up, and it helps them decide if it gets into the next block. It's like her transaction's official footprint on the network.
Okay, so now we know how it's calculated. But the bigger question is, why? I mean, why go through all this trouble? Why not just count the bytes like we used to? Well, this is where we get to the real genius of the whole system. The reason for that discount.
Honestly, the best way to wrap your head around this is to think about airline baggage. We've all been there, right? Your carry-on bag is cheap. Sometimes it's even free. Why? Because it's efficient, you handle it yourself. But that giant checked bag, that's going to cost you because it takes up a ton of space and requires a lot more handling. It's the exact same idea in Bitcoin. Some data is like a lean, efficient carry-on, and some is like a big, bulky suitcase you have to check. And make no mistake, this wasn't an accident. This design was completely intentional. The whole point of these factors was to make spending a UTXO, which is just a fancy term for a spendable chunk of Bitcoin, cheaper. And why do that? To discourage people from creating what are called uneconomical outputs. You can just think of those as tiny, little inefficient fragments of Bitcoin. Kind of like digital dust that can clog up the whole system if you're not careful.
So here's the genius of it all boiled down. That witness data, the part that's just the proof you own the coins, gets a whopping 75% discount. And that creates this incredibly powerful economic incentive, right? By making the proof part of the deal so much cheaper, the network is basically telling everyone, hey, build more efficient transactions. It's a really brilliant way to reward good behavior and keep the whole blockchain running smoothly for everybody.
So what this all adds up to is a system that isn't just accidentally efficient, it is efficient by design. And to really see how big a deal this is, let's do a quick side-by-side. Let's look at the old way versus the new way.
The old way, the legacy format, it was simple. All data was treated the same. A byte was a byte. It didn't have this clever idea of separating out the witness data. But the modern format, with this new weight system, it completely changes the game. By making some data cheaper than other data, that one little tweak encourages a whole new ecosystem of more efficient wallets and smarter transactions.
So if you take away one thing from all this, it should be this. Transaction weight isn't just some boring technical measurement. It's actually an economic signal. It's a message being sent to every single person on the network. And that message is simple. Be efficient and you'll be rewarded. It's such a subtle but really elegant solution to this huge problem of how to manage a limited resource.
And that really leaves us with a pretty fascinating question to chew on, doesn't it? We just saw how one sort of invisible rule can completely shape an entire digital economy. So it makes you wonder what other clever designs are out there quietly building the future of money right under our noses.